Okay, here we go. Everything looks good, and hopefully I shouldn't get the stream crashing today because I updated Streamlabs. But yeah, so I'm gonna start working on the actual Ragdolls today. Like, the joints are pretty much all done. Let me just close this and reopen the right solution. Should also go ahead and make sure we pull the latest stuff from dev. Dev. What's up, Tony? But yeah, I'm gonna actually start working on the Ragdolls, which is exciting. And I've had word with 0x about how we should go about kind of dealing with setting up a Ragdoll. Yeah, so I saw that Hazard got meshes. God, I can't speak. What on earth? But yes, I did see that. So this is the Ragdolls. I haven't really done anything since yesterday's stream, except like pulling the latest stuff from dev. So the current idea that me and 0x has is that we're going to have a Ragdoll component, right? So probably underneath the hinges we'll have a Ragdoll component, which is going to work really nicely with Jolt later on, because they actually have a Ragdoll data structure, I guess. And effectively what this will have is it can have an optional well, no, it's gonna have a handle to a skeleton asset, right? Just like the animation component has. Skeleton asset. Just skeleton handle. Right, and as I discovered yesterday, we actually need a way of disabling the animation component from controlling the transform of the entity, right? Because when we want the entity to actually ragdoll, we need the physics system to control the transform. But currently, the animation component does that. So we need a way of disabling that. Boom, yes. Hopefully not, but probably yes. Since I'm gonna have to deal with the animation system, which I don't know much about. But either way, I'm gonna have a boolean here. Call it control entity transform, which by default will be false, right? So by default, the actual animation system will be in charge of dealing with the transforms. And the idea is that when you want your animated entity to ragdoll, you just set this to true through C# code or whatever, right? Now, I do not want people to have to manually create ragdolls at all, right? Obviously, they can, but I don't want them to have to. So I'm gonna have to write a tool that can essentially take in a skeleton asset, an entity, and then automatically generate physics joints based on the bones in the skeleton, right? And because it's going to actually generate the joints, you can obviously go in and tweak any values that you want. You can completely swap out the joints that are used, and it leaves a lot of flexibility options. So I'm not sure if I I could make it so this stores like the total mass of the ragdoll as well, right? So total mass. Just set that to 10, I guess. Right, and this mass is going to be distributed across all rigid bodies in the hierarchy, right? Based on like center mass and that kind of stuff. So yeah, that's kind of the plan right now. I'll definitely be reworking this in the future and like making sure it's very kind of stable and very usable, because this is just kind of the first idea that we came up with. So hopefully it will work out nicely and I won't have to redo it. So what I'm going to do to start off with is go to the scene hierarchy panel. And probably, actually I want this to be above the joints. Now, I'm not entirely sure if you should be capable of adding this component manually. Maybe we should allow that. That way you can just add it, assign a skeleton, set up the parameters, and maybe click a button and it will automatically go through and generate all joints. Possibly. That way we may not even need like a separate panel to do that. You just add this to like the root entity, set up the parameters, click a button. When will Hazel UI code be fixed? Probably never. Now eventually I imagine we will kind of abstract it away in a nicer way, but it's obviously not something that we're prioritizing right now. But eventually it will be, because for an example, I don't like having to explicitly do this. It would be nice if we could just automatically detect mixed values for all properties. But for now it's fine. And I hope like hell that this stream doesn't crash like it's done for the past 2 days. I hope that Streamlabs fixed that with the latest update. Because it's just so annoying to have to deal with that. So, if is it a skeleton asset that we want? Let's check the animation components. He takes in an animation controller here. What's that? So we probably want a skeleton asset, not an animation controller. I imagine. Skeleton. We may want something like this. You having problems, Tony? Probably want something like this. For now, I don't really care. And to be honest, there's nothing I need to do in there for now. Total mass. Actually, I do have to do stuff in there. But I'm not gonna bother for now. And we need the boolean as well. Where do we add? No, add. Here. Time to crash. Trash hazard, not crash. And I don't want this to be simple, I want it to actually be... The thing is broke, okay. So I had an idea that if you add a Ragdoll component and it has an animation component, we can just get the skeleton asset from that component, maybe? Possibly. You know, sometimes it would be helpful if you can move meshes. You can't? Can't. I can't speak. What do you mean you move meshes? They're all in the world origin. Oh, okay. Yeah. I mean, you could have a local transform for submeshes. If entity okay, now this has an animation controller. You tend to break all of your new features, Tony. Assets. Now I'm trying to get assets. The skeleton that is being animated. Well, I suppose first of all we should get the actual animation controller. Because we need to check if it even exists. If animation controller your editor grid broke again. If this we do Ragdoll Component skeleton handle equals animation controller, get skeleton asset handle. Yeah. So let's verify that that actually works. Why do you break stuff so often? I don't know, man. You break stuff more than anyone else I know. Now the question is also, where is the actual entity transform synchronized with the animation controller? Is that in scene maybe? Update animation, which grabs those. Also, this is completely unnecessary. You can just get the asset and check if it exists, or if it's null pointer or not. Update. Okay, so it's synchronized in here. So that we'll have to check for the Ragdoll component. So, let's open up animation test. Let's delete that. Wait. Oh no, hang on. Just kidding, we shouldn't be doing that. So, if I want to make this a ragdoll, I do ragdoll. We can see we now have a valid reference to the skeleton. Good. And the idea is that you add this component, right? And there's like a button here that says like generate like ragdoll or something like that, or just generate. And that will actually go through the skeleton as well as all of these entities and add the correct joints. And you can obviously later on go in and configure that however you want. Okay. So we were able to get the actual animation for rather the skeletons. Let's make sure we serialize it. And then total mass. Okay. So in here, probably after we end the property grid, we will have... Okay, so first of all, let's just add a little to do. When total mass changes, immediately we redistribute it across the entire hierarchy. But we will have a, for the love of God, bam, done. Been a while since I gotten one of those bots. We'll have a button here called generate ragdoll. And this will trigger us to go through and actually generate everything from the skeleton. Entity Let's just copy this one. Now has a boom. Awesome. And transforms to meshes. Yeah, I mean, that makes sense. You should have transforms in meshes, like a local transform. One second. Okay. That's serialization done. We need to make sure we copy the components. Everything went boom. Don't make camera normally going to the same buffer. Yeah, that doesn't make much sense. Okay, so I think that's it. Hangman's Moose, thank you for following. I appreciate it a lot. Okay, so we have that. Curva has been lost again. Okay, now it would be nice if we could have like a function, maybe in the scene, maybe it's in a separate system altogether, called like generate Ragdoll, right? And you pass in the root entity, which is, you know, this entity. Which is effectively entity 0. Now the thing is, I sort of don't want that to be in the scene. Maybe we can have this function in the scene, but that just calls a different method in some other physics related system. Because eventually this will have to work with Jolt physics as well as PhysX. So I like the idea of that. possibly somewhere here. And then some other physics system would actually do it. Well, sorry, Tony, I can't help you. I suck at that kind of stuff. So if we take a look at how, well, I can actually open that up here. At how, let's see, it's this one. And how we do, how we structure the physics API in the Jolt conversion. Because here we obviously need support for both Jolt and PhysX. And we just have our physics system here, which is kind of the main interface. We could have this essentially have a method called create rigid body, or create ragdoll, sorry. Or maybe that should be in the, well, no, it shouldn't be in the physics scene. Because the thing is, even though it's related to physics, in reality it's literally just a bunch of components in Hazel. Right? Which means that having it here does make a lot of sense. Because then the components will take care of the actual physics API abstraction. Right. So, okay. We do that because we have to get the skeleton asset. And obviously if we don't have a skeleton asset, let's actually make a copy of that. If we don't have it, we just return it for now. We probably want to disable the actual generate button if we don't have a valid skeleton. Now, the skeleton asset has what? It has the actual skeleton and the mesh. Okay. So we care about the skeleton itself, probably. Because that has all of the data. And we can also get the name of the bone. And all of the transforms, which is good. That's what we want. How do I actually get the bones, though? Because they're not here. I mean, yes, like a bone is just this. Yeah. Not sure if that's enough data for me to actually generated properly, but it probably is. All right, one moment, I'll be back soon. And I'm back. Okay. So what I'm gonna start off by doing, because the thing is, this clearly doesn't retain, like, I don't think this actually retains the hierarchy of the skeleton. So I'm not sure. Find bone entity IDs. I mean, we have one which takes an animation controller, but that just uses it to get the skeleton asset. Which it does by doing that. But we already have that. So then it does this, it goes through that, and it does some stuff. So this could essentially be abstracted away by just saying finding bone entity IDs with the actual asset itself. Alright? Now, I think for now, what I'm gonna do is just loop through all of the bones in the skeleton. Did you find the issue? That's awesome. Or was it? Get the number of bones. Get bone name. And I'm just gonna load this to the console. Because I don't think it actually preserves like a hierarchy or anything like that. Or stores it at least. So we may have to figure that out. I'm also wondering how we're going to sort of figure out which joints should apply to what bones, and also how kind of what settings we should use for each joint, as well as mass distribution. But I guess mass distribution could technically be based on like the scale of the bone. Technically, but I don't know if that would be like the best option. Let's open up animation test. Select this dude. Give him Ragdoll, which has that. Okay. Now, is that an actual asset on disk? Is my question. Skeleton. I think it is, yeah. Stop playing the animation. And click that. Hips, spine, spine 1, spine 2, neck. Oh, so is it sort of maintaining a hierarchy in a sense? Because in that case, I would expect head, top, end to be printed just before the left shoulder, maybe? Yes. Okay. So that's good. It does preserve it to some degree. It's stored kind of like linearly, but in the order of the hierarchy. Okay. Because that effectively means that we can use this as an index into the children of the root entity. Sort of, but not quite. Because this goes through all of the bone names. If we need to get the entity, so what was that called? Try get descendant with entity with tag. Bone name. And what does that actually do? Alright, so it goes through all of the children, does it recursively, and if the tag matches, it does that. The problem there is these entities are called like Mixamo, whereas the bones aren't. Because if I go in here, entity being the root entity probably, because in that sense in that case we could actually just do auto reference bone name in bone names. Do this. Root entity. Bone name. Right now I'm just kind of trying to wrap my head around how this is going to work. I bet the order in this is some of a boom. So, because if I can figure out kind of and wrap my head around this, then I think it's going to be a lot easier to actually get it working on the first go. And I should start using the shift clicks to select the topmost parent. So if I do this... Oh! They're actually called this in... The bones are actually called like Mixima Rig. Now obviously if we don't find any of these at all, then it's not a valid skeleton for this hierarchy maybe? Maybe. I think this is a good kind of initial way of doing it. I'm gonna close that. Because if we can actually get these, you just realized what boom. So okay, let's do this. The bone name. Continue. Now I think in order for us to do okay, so we can get the translations and the scales all as kind of one thing. Get parent bone index. I'm copying the uniform data to a local buffer so I can then upload it later without it being garbage, but it gets overwritten for that. Awesome. So what does this do? It checks if it's... And then it just returns the index of the parent bone. Okay, that's interesting. Because that technically means we can iterate from it through it like kind of backwards, right? And then just get the we could get the last bone, then we can iterate through all of the parents, right? And I think that could be a bit more efficient, potentially. Would it though? We'd also need... No, actually I think iterating through the parents and connecting up the children is better. What do we do if a bone has... Can a bone have multiple children? I don't think so. Like if we take a look at this dude. Well, I mean the hip bone does have multiple children. So how would that work? Because we'd want this to be connected both to the legs and to the spine maybe? Or have all these be connected to the hips? But you can't do that. Tony, I'm gonna open up Unity. Because I know how much you love Unity. Because I need to see how they do it. I don't care. So if I go to this dude, which is the exact same one, we have hips, which doesn't have a joint. And then these have joints. Except, because the way I generated it. And these connect to the hips. Oh, interesting. Yeah. If we iterate through the hierarchy from the child, right? So this, for example, would have, if we look at the foot would have a joint that's connected to the leg. What? Okay. The leg would have a joint that's connected to this. And this would be connected to the hips. This would also have a joint that's connected to the hips. Okay, yeah. That makes sense. So you can come back, Tony. We've closed it. So these three would have joints that connect to the hips. The hips would have a rigid body, but no joint. Effectively. Or maybe it would. Okay. So then it does make sense that we would iterate through it backwards and then get the parents. Until we reach the parent that has the until we reach root entity, basically. Okay, that makes sense. So we would get the bone names, and then we would get the last bone name, right? So we do get bone name for get the number of bones -1. Probably yes. Last bone name. Then we do get bone index for the last bone name. Okay. And we want to do skeleton. Get parent bone index from last bone index. Next bone index, maybe. We'd also need the actual entity for this index. So let's call this current bone index actually. And the next bone is going to be the parent bone index. So and okay. Which bone would that be? Probably one of the toes, maybe? So while we have a next entity, we want to do this. This isn't entirely true because actually, is it? Yeah, I think it is. Okay. So let's just for now do and then at the end we want to set the current bone entity equal to next bone entity and current bone index we want to set the current bone index equal to next bone index, because the thing is this won't strictly be correct, I don't think. Maybe it will be. Now the current bone entity equal to next bone entity. Because that way we just print current bone entity name. I don't think that will fully do what we want, but I think it will be close-ish. Generate. That's taking a while. It's completely frozen. Did we accidentally throw it into an infinite loop? I think we threw it into an infinite loop. I mean, what I could do is say if the current bone index is 0, break. Because that shouldn't be an infinite loop. Six to 3. I haven't had any booms, although I do have an infinite loop apparently. Why is that? Because we grab that. Oh, we never increment next bone index. Because we need to get parent bone index for the current bone index. Yeah, because that would get its parents. So that's why we have that. It's going to just some weird infinite loop. And this should technically print it out in reverse order of the hierarchy. Generate. We get a crash. Why? Because we tried to... Okay. So as long as this isn't the first bone, we should take care of it. If it is the first bone, the current bone index is 0. Well, no, if it's greater than 0, we do that. Well, what we could do is just, if current bone index is 0, break. Should probably set animation test as the startup scene. Okay. So that went to this, but not to hips. Because hips would be 0. And we don't do that one. And you can see we go up to... Okay. Hang on. Because this will obviously only do the very last bone kind of structure like this. It won't do left up leg, it won't do spine. What we probably want is... we want to get all of the children of the first bone entity and do this for all of them. Right? Yes. So this would actually be get bone name for the first one. Root bone entity is equal to this with root entity and tag like that. We would then go through child ID in root bone entity children. We would find how would I do that? We'd have to find the index of, for each of these children we would have to basically go through and find the very last child in its hierarchy, get the bone ID for that, and then go back up. Right? Yes, exactly. So we go through all of the root bone entities children. We have to go through all of their children and all their children all recursively until we get to the last one, which doesn't have any children. At which point we would get that entity and then go back up. Right? So I may need a helper function for that, so we don't have to duplicate a bunch of code, because we need to call it recursively, effectively. Actually, do I? I don't think I do. Because if I just iterate through all bone IDs... Yeah, no, I don't have to do any of that. I don't think. So, okay, if we comment out this entire pile of garbage, we do... current bone ID. We do it backwards, so we get the number of bones -1. SpongeBob the Chef, thank you for following. Very much appreciated. What's up, man? So if the current bone ID is greater than or equal to 0, because we want the last one. Or do we? No, I don't think so. We increment it. Sorry, we decrement it. Because this will go through exactly everyone. Then we go entity, current bone entity, which is going to be try get this and an entity with tag of root entity or root bone entity. I think root bone entity. Oh, that's you. Hang on. I'm sorry, I don't remember your Discord username. Ah, yes, yes. In today's episode of Peter Fix Hazard, we have memory failure. Yes. Now with the skeleton, get bone name here. Or the current bone ID. Right, so we do that. We also need current bone parent, right? Which will actually have to be root entity as the parent, because this could be root bone entity as well. And in fact, I probably want to do you in HTT, parent bone ID, skeleton, get parent bone index. Oh yeah, because an index on ID. Name that correctly. Parent bone index. Whoops. Parent bone index. Okay. I think this is correct. This should go through exactly everyone, and because we will basically give current bone entity a joint, maybe, and then that joint would be connected to the parent. Yeah, that makes a lot more sense than what I was trying to do. So it's just what I was doing previously. That's just a pile of garbage. Current bone. Current bone entity, name, current bone, current bone parent, name. This should go through every single one in the exact right order, I think. Okay. I'm hoping this gives me the correct result that I want. This one generates. Okay, so that right toe base, right foot, yep, that goes to hips. Then we go through the left stuff. Then we go through the entire upper hierarchy until we reach the spine, and that parent's bone is hips. So that is in fact correct. That is exactly what we want. Now I'm not sure about this structure personally. With this having the ragdoll, this being the mesh, and then the kind of armature going on here. But I can probably work with it. So, good. Now I have that. Next I need to get the transform stuff. So translations. Bone translations. Rotation and scaling. I think we will use scale to kind of determine if a bone should have a joint at all, right? Because I don't think it makes much sense to have like the toe bones be connected via a joint. Rotations, bone scales. Let's do that. Translation. Rotation. Scale. Now the rotations are stored as quaternions. Okay. Which makes sense. Bone translations at current bone index. Bone rotations. However, I want to convert them to Euler angles. And I'm probably going to convert them into degrees as well. Just so they're a bit more readable. That not correct? Hazard broke, not surprising. That's that one. That one. What's the problem? Oh. There we go. So this should print all of the transforms. Now I don't know if they're stored in local space, like relative to the parent bone. So what? Let me guess, you can't actually format the beg your pardon? Wait, does it work for the translation but not for the rotation? Everything broke. Awesome, dude. Time to eat it and start again. No, it actually can't format vector 3s. Which is weird. We need to provide custom formatter, FNT formatter. Okay, let's do that. I'll probably just slap it in here because it used to be using this, but that has changed now. So you need a. Is this actually in a namespace? It is. We need formatter for the type of glm.d. Okay, sure. Let's just copy this entire thing. Are you happy now? Will you let me print my vectors? I'm actually kind of surprised the stream hasn't crashed yet. So maybe they fixed it in the most recent Streamlabs update. Should probably have a separate file for like custom format structs. Okay, so now it works. Good. Generate. Let's see. And I think the first ones would be they all have a scale of 1. They all have unit scale. Probably because it's been applied or something. Well, that's annoying. What about the actual entities? So if we check like yeah, they all have unit scale. Which is mildly annoying. Because that means I can't use that. Now I could probably get the distance from, depending on where the origins are, from the child to the parent, to sort of try and determine a rough approximation of the length. The question is, does it go from the origin or from the end of the bone? Is the question. Okay, let's open up Blender, check out what it actually looks like. No, thank you. Delete that. Let's import. I believe it's GLTF. Ragdolls. Source. Stormtrooper. Yep, it's GLTF. Okay, so it goes from the start of the bone to the end of it. Alright, so we can see the start of this bone is here. The start of this one is somewhere like around here. How is it viewport displays in front? That's a problem, because that means that if I get the distance from this point to this point, that's the length of the next bone, not the current bone. I mean, there has to be a way for me to get the actual, the real scale of the bone. Somehow. Because if I check this bone, you can see, like, how does this equate to 1? It doesn't. That means it's been normalized. Okay. Let's have a look in here. Skeleton. Import skeleton, which returns that. Import animation. That's not actually what I want. I specifically want to take a look in here. And this is using the scene. Bone hierarchy. Which is... okay. Construct bone hierarchy. Extract bones, which does that. Okay. So we created from that with a traverse node. I may have to send Xerax a message and ask him how the hell I get the actual like size of a bone. What? I think I'm gonna have to do that. I mean, I could possibly take a look at in here under update animation, bone transform, get model space bone transforms. Oh, interesting. So maybe we should do that. Why doesn't it need a mesh? Just to get skeleton. Okay. We can maybe use this to do it. Which we'll take the actual skeleton instead. Yeah. We already got the skeleton. Ooh, you fixed it, Tony. Good job. So we'd actually have to compute that. Oh, that's annoying. We'd effectively have to do this at least once before. Yeah, I think what I'm gonna do is under scene hierarchy panel. Not in here. I'm gonna have a vector. Do IDs, call it bone entity IDs. It will grab this. We will do if Ragdoll component size. Well, if it's empty, or if its size is not equal to skeleton numbones, then we need to call get mod space bone transforms. No. At that point we need to iterate through all of these. We need to include the last bone. We need to do try and get the summoned entity with tag root entity. Skeleton get bone name for the current bone index. Entity bone entity. Still won't move. Literally forgot to call from the command buffer. Begin to set frame index. Awesome. It's progress at least. Okay, so we have bone entity. We need to check if not bone entity, then something's fucky. Let's just fail to find entity for bone. Let's actually do other things. And let's just fail. Making sure to do clear. Now this is complaining because how would this execute infinitely? We grab the last bone. We loop while it's greater than or equal to because we can never go -1. Ooh, okay. Yeah. I mean, okay, this loop we could do normally by setting it to 0, saying that while it's, because here it doesn't actually matter, while it's less than skeleton get non-bones, and do current bone plus. Because in this case it doesn't matter if we iterate backwards or not. Can you go away? It's not going to execute it infinitely. So we grab the name, we grab the entity, we say if it's not valid, we bail out. Otherwise, actually what we should probably do here is clear it beforehand and then reserve, resize, so that it fits the number of bones. So it's a bit more optimal, because that way we can do current at I is equal to that. And we obviously need this. Alright, current bone index. And we obviously need this vector so we can get the model space transforms. Right. So model space transforms, and things I don't know if this is correct, if we actually need the model space transforms in order to get the correct scale. Right, so we do that. We need to decompose them. Into known translation, then scale, and we need a quaternion with bone location. Let's see if this gives me the correct values. Let's see. I'm hoping it works, because if it doesn't, I'm gonna have to have a chat with 0x about it. Because if I can get like the actual correct bone scale, then I can say if it's below a certain threshold, we don't want to generate any joints for it. Or maybe we generate a joint, but it's like a fixed joint, so it doesn't move. Oh yeah, I'm gonna have to use fixed joints for this as well, because we may not want like the toes to be able to rotate, but they still need to follow along. means I'm actually going to have to properly test fixed joints as well. And then there's also the question of how do we determine which joint to use. We can say obviously if it's not big, if the bone isn't big enough for a, I don't know, let's say a D6 joint, then we could say, okay, let it have a fixed joint. And totally messed up again. Which isn't that surprising. Yeah, no. Why isn't scale a thing that we keep track of? Get bone scales, which returns this. Okay, and these are all relative to the parents. But why is bone scales... Okay, so it decomposes to transform into these. Okay. If we then do, where is this called? Traverse bone. But it's not scale 1, because this would be the one, like this minus this. That would be the actual scale. Yeah, I'm gonna have to send a message to 0x and say, hey, I need to know the scale. And this does not actually get the correct scale. Because I don't think this would have a scale that... Like, this shouldn't be considered a scale of 1. I mean, sure, relative to itself, absolutely, that's a scale of 1, but... Relative to the parents, relative to the mesh? No. It's... Okay. Yeah. Let me make a note of that. Because for now, all that means is I'm just not going to check that. Okay. So I guess for now, just don't bother with it. At all. However, what I will be doing right now is just go if first bone entity class component because they need rigid bodies, they need colliders, and they need the actual joint. Collider is interesting because it kind of depends on which bone it is. Like the arms would have capsule. I know unit is sometimes gives the torso a box collider. But I'd say a capsule collider would be better for that. So, if it has rigid body component, I will remove that. Oh, we can just call remove component if exists rigid body component. That will collide out of component. And we'll use a configurable point for now. Because the thing is, the scale will also be quite useful to determine mass, right? How much of the total mass this particular bone should kind of have. Because if it's a really small bone, then arguably it shouldn't have that big of a mass, right? So, because like the majority of the mass or something like this will be concentrated around this area, right? Around the hips, because these bones are the biggest, right? So we can use the scale of these bones to determine sort of a factor of how sort of much it should be, right? So we could, for example, add together all of the scales and then divide this by divide the total by this, maybe. We'd have to normalize it to be between 0 and 1. Right? 1 representing this will have all the mass, 0 representing it will have none. Yeah. So knowing the actual true scale of the bones is very important. Capsule collider component. Configurable joint components. I need to tell this that it's going to be dynamic. I'm not going to give it any other feature like values right now. Capsule collider component will have to figure out as well. This one, however, we can actually tell it that the connected entity is going to be current bone parent dot get UID. We'll have to figure out the anchor offset as well eventually. But if I just do this, then in theory we should get all of the entities having the correct components at least. Well, mostly the correct components. Because there's so much of this actually relies on me kind of being able to tell which bones are sort of the biggest, right? So what the scale is. Because if the scale is too small, then we probably want a fixed joint component, not a joint that can actually rotate. The scale will factor into the mass weight distribution. And it will also factor into how big the collider will actually be. Alright, so if I select this, I do generate. We can see rigid body, configurable joints, capsule collider. all of these three should have their joint be connected to the hips, which they do. The spine should be connected to spine. Well, spine 2 should be connected to spine 1, yep. But obviously, the problem here... Oh no, crap. Let's reload that. Hit generate. Right forearm is connected to right arm. And then we obviously come down here and we have like fingers and shit like that. Which arguably shouldn't have this. Right? Now the interesting thing here is I can actually, if we move this up and remove the animation component here, in theory we should get something resembling a Ragdoll. In theory. No, we get a crash. Because... Oh, because I know why. It's because this doesn't have a rigid body. And I think we have to add that explicitly. Right, because we don't want the root bone entity to have a joint. But it does have to factor into the mass weight distribution, probably. Also, I should make it so that's not an actual crash if you don't have a rigid body. No. Load up animation test again. Let's check. Okay, good. Yeah, and I'm gonna have to regenerate it. So this one has a rigid body now. Okay, let's see. What? Okay, what happened there? I suspect collider issues, because that's interesting. Not sure what's happening there. Where am I? There. Yeah. Physics was not a fan of that. Is it because the mesh isn't stored on the correct one? Like, what if the mesh is stored on the hips? Because that's kind of the origin of the entire thing. Because I think the problem is because the parent object isn't taken into consideration. Maybe. Well, it could also be the fact that we remove the animation thing from here. Right? Because that is kind of what gives structure to the entire... That's kind of what links the mesh and this together, I think. But obviously we do this, nothing happens. So maybe it's time to go and say in update animation in here. Right, because this will actually do this. But interestingly enough, there seems to be some stuff related to root motion here. But I don't think that's necessarily what we want. No, it isn't. So what I could say is that if the entity has a Ragdoll component and this is true, because at that point we need to synchronize the transform of the entity with the actual transform of the rigid bodies. Yeah. Yeah. Why did I get a random welcome to the chat room displayed in chat? That's a bit weird. Okay. Because we do this, and okay. If it has a valid animation, I mean, it technically doesn't matter in this case. We could say if e.has components, Ragdoll component, right? And that component doesn't have yeah. We can do transform controlled by Ragdoll is equal to that. So if that's false and we have a valid animation controller, then it's all good. It should kind of do what it wants. But if that is true, then this code won't be executed and it should fall back towards the it should go back to having the actual rigid body take control. Although we may have to write in a special case for Ragdolls. So that is now not true. So if we simulate, nothing happens. And if we tell them to play the animation, that happens. But if I check this, then we get that. Absolute weirdness. Now, I'm not sure why that's happening. It could have something to do with us not kind of dealing with this, because we need to get that. Maybe? That's a good question, actually. Take a look at spine. What's local skills? Okay. But I mean, now this sort of works. Because if I tell it to not have that, then we get the normal thing. The question is, why does it freak out like that? Let's take a look at the spine here. Yeah. It is completely freaking out. Is it because it's breaking or something? Because we don't have intercollision enabled, meaning that the fact that the colliders are in the exact same place doesn't matter. So let's first of all say that these are not breakable, because I don't think we will want that. Let that look false. Anchor offset, maybe could be a problem, although I don't think so. Angular motion doesn't really matter too much. Let's give it a go. It could also be just the fact that we're synchronizing it weirdly. Let's regenerate that. It's no longer breakable, which is exactly what we want. Let's say control, and it still freaks out, although the freaking out somehow looks more coherent or something. Okay, what I'm gonna do is build it in debug mode and open up the physics debugger to see kind of what's happening. I suspect it's something to do with transforms being weird or something like that. Also, I'm probably gonna head out in like half an hour. But it does seem like Streamlabs fixed the whole crashing issue that I was having yesterday and on Monday. Because I've been going for 2 hours and 15 minutes and it hasn't been interrupted at all. Which is nice. Ah, so I broke yet again. Shocking. Okay, let's open up this special debugger, which is absolute trash. Also, I'm actually I've been considering maybe doing some live streams when I'm playing on the Cherno Community Minecraft server. So I think that could be something different. Let's open up this. Start debugging. Okay. Is it because of the intercalation? I mean, that's not enabled, so I don't see why you're a failure. How come? Oh, what's up, Marco? So I'm wondering if this freaking out is due to intercollision or some weird shit like that. Oh, is it actually visualizing joints for once? It didn't used to visualize the joints. Or at least not hinge joints. But yeah, it's actually visualizing the joints. Which is interesting. No, I'm done with D6 joints for now. They pretty much work. At least they have the correct parameters that we need in order to have ragdolls. So I have actually started working on the ragdoll thing, and this is kind of the result. It just freaking out, and I'm wondering if it's the colliders or the joints that is messing it up. Because if it's the colliders, then yeah, I don't know. But if we open up joint testing, you can see turn off the bloom because it's annoying. This has a D6 joint which has free motion in all axes, and you can see it looks just fine. and that overrode that, but that doesn't matter too much. Okay, if we do not add a capsule collider, will they still freak out? Is the question. Because you wonder if mono would be less pain at the moment. Maybe. Yeah, I'm actually super happy with the joints. Because like I'm not the kind of person who like enjoys testing features most of the time. But I've been having so much fun testing the joints. It's absolutely amazing. And I actually ended up spamming the Studio Cherno Discord servers physics channel with just videos of the joints working in Hazel. Okay, let's open up animation test again. Because if it was the colliders and now I've disabled the colliders, then they shouldn't freak out. If it's the joints themselves, well, then I will cry. Where is it? It's here. Let's regenerate so it doesn't have any colliders. Now it just have joints and rigid bodies. Yeah? Oh, I forgot to turn on the control and transform setting. Aha. Interesting, interesting, very interesting. Let's maybe not use debug mode anymore. So it's probably the joint or the component. So let's, for now, lock them. So this is a configurable joint motion type. Let's lock all of them. And try that. Time to visualize matrices in the UI. 1. Because if I lock the motion, then they can't rotate at all, making them effectively fixed joints. So regenerate it. I'm sorry. What's up? That's very weird. What if I disable gravity? Is it possible that they all kind of fall in a weird way? Which is causing the mesh to freak out, or we're just not synchronizing the transforms correctly. Yeah, I think it's that we're not synchronizing the transforms correctly. Because now it shouldn't be affected by gravity either. Because gravity is disabled. I'm gonna try something. So it's the Stormtrooper mesh subindex 0. Stormtrooper 0. That didn't look better. Let's try pasting it onto... Oh, we need to paste this new thing. Let's try this instead. No, it's still happening, so it's the way we're synchronizing transforms, I'm guessing. It could be something as simple as we're trying to set the transform in world space, but they expect local world space or local space. Unless the animation thing is still screwing with it somehow. Who doesn't love Ragdolls exploding? Exactly. Yeah, it's one of those. Yeah, so I'm suspecting, let's maybe do something else here. If I do a hinge joint instead, it could be the fact that the joint isn't configured in a good way, or the transforms are weird, and we end up creating the joint in strange places. Potentially. Regenerate it. Make sure that it has only one joint. Let's hit simulate and we get this. We get a crash. Because we haven't set the damn... No, didn't want to run it. Because I forgot. Set the connected entity. That's why we crashed. You hate your own engine, Tony. Wrong scene. Regenerate? Yeah, I think it's a matter of synchronizing the I think we're just synchronizing the transforms incorrectly. Let's maybe try fixed joints, because they have no rotation. Although I don't even know if they're gonna work properly, because I haven't like actually tested them since I did the rewrite here. Yep, that's exactly what's happening here. We're just synchronizing it weirdly because fixed joints don't have rotation, so I know it's not the joint itself, it's the synchronization that is messing things up. And it's not the collider. And it's not gravity screwing with it, it's exactly what I suspected it was from the beginning. Yoink. So let's... We will also need a fixed component here because we will use that for some things. But yeah, so I'm probably actually time to continue working on Fritex. Sounds good. I'm about to end the stream here either way because I'm gonna have to talk to 0x about some stuff, and then after that I'll have to fix up the whole transform thing being synchronized wrong, incorrectly somehow, for some reason. I don't know why. But yeah, I decided to basically have a word with him about a lot of stuff. So is it this one? Yes. But yeah, so I'm gonna go ahead and end the stream here. I'm really glad it didn't crash. Don't know if I'm gonna streaming tomorrow, depends on if 0x has contacted me. I may actually stream some Jolt development instead. But yeah, thank you everyone for watching. Have a good rest of the day / night, and see you later.